Okay, Booklet D, Part 2. I got up to trigonometry graphs in Part 1. The next thing is spheres, cones and pyramids. Going to just miss that out for a sec. If there's time at the end, I'll come back. If not, could be an extra video on that one. But we're going to pick up some of these A&A star topics, the sine and cosine rule, area of a triangle, arcs and sectors. Maybe then do a little bit of similar shapes in this one. But we're going to start with a little bit of a tutorial, however. Our journey in this booklet begins on the top of page 14. This box is taken straight from your formula sheet. Okay, what we're looking at here now is triangles that are not right angle triangles. Right angle triangles use Pythagoras theorem, use trigonometry, and use base times height divided by 2 for the area. Non-right angle triangles, we're going to use these: the sine rule, the cosine rule, and instead of that base times height divided by 2 for the area, we're going to use half AB sine C. So basically, big angle A is opposite little a, big angle B is opposite little b, and big angle C is opposite little c. Sine rule I often refer to as the pair rule. It looks at pairs, for example, that angle with that side and that angle with that side. Okay, the cosine rule relies on a triplet, which I'll show you in a minute, and it's the same triplet used for the area rule. So as long as we eliminate pairs, we know it's not the sine rule, and we can start looking whether they want the area or another side that we can find with the cosine rule. It'll make more sense with some examples. Now we'll come back to the book in a second, but let's start here. Okay, in this question, I know this angle, this side, and I want to find this angle. So my gut is telling me this is a pair that I can use in the sine rule. This is another pair where I know the side, but I don't know the angle. So the sine rule tells us that the sine of this divided by this side is equal to the sine of this divided by this side, or sine big A over little a is equal to sine of big B over little b. I'm going to jump straight in and write then sine of what I want, always start with what you want, divided by what's opposite it is equal to the sine of this divided by what's opposite it. Okay, I want to find theta, so at the moment I'm thinking let's move you, instead of being a divide by 10, you go up there as times 10, and I'm simply going to put into my calculator sine 42 divided by 16 times 10, and that comes out to be 0.418. Sorry, I'm rushing that. I hope that is correct. If you get something different, please do let me know. Like in any one of these booklets, I'm hoping to get everything right, but things can go wrong. I'm not quite finished though. That's sine theta. In this case, I've got to spot that and go, actually, what I want is theta, so the sine needs to go over sine minus 1. Right, the opposite is sine of this number. Put into your calculator like that, and you get, well, I get at least 24.7, and as it's the angle I'm finding, that's degrees. Okay, very similar looking triangle down here. Again, I'm spotting these pairs, angle opposite side. That's a pair I can use. Okay, there's another pair where I only know one of the two things. This time though, it's the side that's missing. Now, what I tend to do here is put the sides on top. The sine rule is completely reversible. Okay, so whereas here I put the sine of the angle on top and the sides underneath, here I'm going to put the sides on top and the sine of the angles underneath. So I'm going to start with what I want, which is x. His partner is 58, goes on the bottom, but it's sine 58. That divided by the sine of that is equal to that divided by the sine of that. Now, a similar pattern, what I said in the last one is I don't want it to be divided by anything. Let's move you up as a times sine 58. And again, out with my calculator, that divided by that times that is equal to 7.6, and this time I'm finding a side, so we're centimetres. Nothing else extra to do here. It's x that I wanted and it's x that I found, so there's no kind of like sine minus 1 or whatever that we have to do up here. So that's the sine rule, pairs. We're looking for these pairs, angle opposite side. The cosine rule. Now, I know this angle but I don't know this side. I know this side, but I don't know this angle. I know this side. You get the idea. So there are no pairs that I know, so I eliminate the sine rule. In fact, what you're looking for to use the cosine rule is this triplet: side, angle, side, with the angle between the two sides. You know, I kind of circle it like this normally. Okay, and the cosine rule is a squared, and we make the one that we need. So this, to find this side, is equal to b squared. Doesn't matter which one of these we call b. I'll go with this one. Plus c squared. I'll call that one c. Minus 2 times b times c times the cos of big A, the angle there. Okay, how would it look for here? This one squared is equal to 16 squared plus 14 squared minus 2 times 16 times 14 times the cos of the angle in the middle, 35. Now, with a Casio, I didn't have the luxury of a Casio at home, but with a Casio you should be able to type that in like that, and it'll just give you the answer, okay? I've had to kind of split it up and do, but if you try it on a Casio, hopefully that comes out to 85.02, depending on your roundings. You should get close to that at least, okay? Again, I wouldn't round to, I'd go to 2 or 3 decimal places here. Save 1 decimal place for your final answer. This is a squared. In order to find a, I need the square root of that. And again, into my calculator I go, and I get 9.2 to 1 decimal place. Now, what I'm about to show you is probably the least likely, okay? I've done the sine rule to find an angle. I've done the sine rule to find a side. I've done the cosine rule to find a side. Now, the cosine rule to find an angle has a weird setup. In order to find an angle with the cosine rule, you basically need to know all the sides of the triangle. Okay? You need to know little a, little b, and little c. Now, if we look here, okay, the cosine rule, the only angle in it is here, but you've got little b, little c, little b, little c, and you've also got little a, and you'd need to know all those in order to find that. What is massively important here, though, if you do have to do this, is the labelling. If this is the angle I want to find, this becomes big A, making this little a. But if it were this angle I wanted to find, that would need to become big A and that little a. Similarly, if that were the angle I wanted to find, that would become big A and that little a. But in this case, let's go with that setup. The other two, it doesn't matter, which is B and C. It's just getting that A in the right place. Find the angle you want, opposite it becomes little a. Okay, I don't want to waste time copying that cosine rule again, okay, but I am literally going to put A, B and C in instead of those. So A squared becomes 10 squared equals B squared becomes 15.6 squared plus C squared becomes 12.2 squared minus 2 times B, 15.6, times C, 12.2, times cos of angle A, which I don't know. I really sincerely hope you don't get one of these. It's probably the most awkward to rearrange, okay? Let me do it really quickly for you. I'm going to work out all these squares first of all. 10 squared. This squared plus this squared, if I can find it, I get to be 392.2 minus, I'm also going to do 2 times this times this. I obviously can't do this, I don't know this, but 2 times this times this is 380.64 cos A at the end. Okay, now this is negative, okay? It includes the thing I want to find, but it's negative. For me, I would rather this come over the equals and become positive, and the 100 can come over this in its place and become negative. So I get 380.64 cos A equals this, take away this, 292.2, 100 off that, okay? That is times in the cos A, so cos A is equal to 292.2 divided by 380.64. I'm running out of room on this page, so I'm going to put the answer to that right here, if you don't mind. It is 0.768. That's cos A, so A is equal to cos minus 1. Take the cos over of that number. And again, hoping I'm right, 39.9 degrees. We're going to get a chance to see all these play out in some actual questions in a second, but finally, it's the same setup as the last page, this trio. Side, angle, side. But it's that same trio can be used to work out this side using the cosine rule, but can actually be used to work out the area of this triangle using half AB sine C. In this case, okay, this becomes little a, this becomes little b. By default that would be little c, so this angle becomes big C. For you, just learn, well, if you got that trio, put one of those numbers in for A, one for B, and the angle for C, right? Don't need to overthink it. So I'm going to put 16 in for A, 14 for B, and sine 35 straight into my calculator. And I get the answer, again, 64.2. We're looking at the area here. Assuming these are centimetres, then the area would be centimetres squared. Now, you may get arcs and sectors as a different question, or it may be kind of tagged in with this question. I'd like to think they'd separate it out, but let's just have a look at what I mean by arcs and sectors, okay? Parts of a circle. This line here, which is part of the circumference of the circle, is called an arc. The slice itself has been taken out of the circle is called a sector. Right, if we consider the circle as a whole, which we can't see the rest of it, we just got this chunk, okay? The area of the circle would be pi times r squared, but we can see the radius is 15. And the circumference of the circle would be pi times the diameter. Well, if the radius is 15, the diameter is 30, so pi r squared, pi d, okay? However, if you want just this part, then the fraction of the circle we're talking about here is 82 out of 360. So both these can be times by that fraction, and in timesing by that fraction, 82 out of 360, I'm finding the area of just this fraction, or I'm finding the length of just this arc rather than the whole circumference. Okay. Again, I'll throw the answers into this, but I don't think that's the most important bit. It's just understanding that. I would say is the important bit. Okay, so the area of this 160.9 centimeters squared, and the length of this arc, pi times the diameter, but just this fraction of it, and it is 21.5 centimeters. Okay, how does this look in here? To page 11. Nope, to page 14. Okay. Again, I'm not going to talk you through every bit of working, but just what I see, my observations. In this question, I was asked to find the length of CD. Okay. I noticed that I had these two sides. I thought to myself, if I can know that angle there, okay, then I've got this trio. Right, and I can use the cosine rule with side, angle, side, this trio, in order to work that out. However, I don't know that at the minute. How then? But look, in that angle is the same. These are vertically opposite. These angles are the same angle. On this triangle, I noticed I had a pair. Angle opposite side, side opposite. Don't know that angle, but we want to know it. So I've circled my two pairs. So basically what I've done here is I've used the sine rule. The sine of that divided by that equals the sine of that divided by that to find this angle, 30.6 degrees. If that's 30.6, so is that. And then I've used the cosine rule, where this is A, B, C, and that's big A. And I've put my three numbers in for B, C, and big A here, and worked at the size of the side to be 5.3 centimeters. Next up, top of the next page. Again here, I'm asked for the area. Now, that area again relies on that trio. Now, this is going to be awkward for you to see. Because they've given me this side and this side, I thought the trio that I want is here. Side, angle, side. But I don't know this angle. But looking at it, I then noticed I had a pair. Angle, opposite side. Side, opposite. Okay. So I can use the sine rule to work at this angle, right? But that isn't the angle that I'm going to need in the end, it's this one. But if I know 2 out of the 3 angles in a triangle, I can always work the third one out. So, what I've done again, briefly, I've said that the sine of this angle divided by this is equal to the sine of this angle divided by this here. And I've gone on to work at the size of this angle to be 60.3, which I've written there. I've then taken these two away from 180 to get 73.7, which is this angle here. That's the trio I need, side, angle, side, and I've used it with half AB sine C. So half times that, times the sine of the angle 73.7, which you can see there, and there's my answer. Sometimes they'll play the area questions in reverse. Here's an example. Okay, side angle O. I've only got 2 things, I always need a third. Don't know this side either, so I'm not using the sine rule, but I could really do with that. However, I am told the area is 42.6, so what I'm doing here is I'm working backwards to find this side, knowing the area. So the area rule is half times this, times this, times the sine of this, or half AB sine C equals this, which is what I've written here, but I've put x for the thing that I don't know. Half times that times sine 72, ignoring the x for a minute, is 2.948. Those 3 things have times to give that, but I've still got x, okay, is equal to that, and then simply divided that by 2.948 to find what x is, which is 14.5 centimeters. All right. Okay, in this one, my long-term goal is to find the length of BC. I put a question up originally, but I've actually then swapped that for an x. Not quite sure why I did that. I noticed to begin with, the only thing I knew about this bottom triangle was an angle and an angle. Not really any good to me to know 2 things. I'm going to need to know 3. However, I've got this trio there, side, angle, side. So my thoughts were, okay, use those 3. Use the cosine rule to work out this side. Okay, then once I know this side here, which I've worked out to be 37, I'll show you how in a minute. I will then know angle opposite side, angle opposite the side I want, 2 pairs. So I'll be using the sine rule to find a side. Okay, and this is how it plays out in numbers. So first of all, the cosine rule, using these 3, getting me that answer of 37. Okay, then that 37 goes there, and I've used the sine rule, that, put in the side, the thing that I want on top, that divided by sine 23 equals that divided by sine 112. In order to leave x by itself, the divide by sine 23 has gone up, which you can see me doing there, and my answer is 15.6 centimeters. Now for this. Okay, I'm just going to let you have a little look at that. What I've done is I've stripped out this big triangle here, ECA, and I've put on the lengths they've given me, which are 8, 11, and I knew this 31. So I kind of got this trio, and initially I'm asked to find the length of AE, fine. Got the trio, want the other side, cosine rule. Okay, pretty simple on that one. And then in this part I was asked to work out, well actually I was asked for this angle, and I would ignore this, I wouldn't worry too much about this, but that angle is the same as that one because of the alternate segment theorem, circle theorems. Again, don't worry about that, but let's just pretend for a minute we were asked for this angle. Knowing what I've also worked out there, 5.8 to be this side, of putting that there, I've got that pair and this pair. This is the one missing, so sine rule to work that one out. A few more for you. what have I done here? I've decided I need this angle to get this trio. Once I know this trio, I can use the cosine rule to get this side, or the area rule actually to find the, because that trio is the same trio to work at the side or the area, and that's exactly what I've done. Alright, I've worked out the angle first of all. I've worked out that actually there would be 18 of these triangles all the way around, so if I've split that 360 into 18, so this angle is 20. Here's me using the cosine rule to find this side, which I found to be 4.2, but the whole perimeter, I've counted there would then be 18 of these x's all the way around, so times my answer by 18. And down here, worked out, used the 20, the 10 and the 7. This time not the cosine rule, I've used the area rule. Half times 10 times 7 times sine of 20 degrees is 12, but there'd be 18 of that triangle around again, so again I've times the area by 18 to get that. Okay. Arcs and sectors. What we're going to do actually is I'm going to take a break there. I'm going to pick up with arc sectors, similar shapes, and go back and have a look at spheres in part 3. Hopefully I'll see you in part 3. I'll catch you later.